Good afternoon, everyone. Welcome to today's webinar, Cooling Strategies for 5G Growth. Thank you all for taking the time to be here today. My name is Jacques Moravan, and I'll be your moderator for this webinar. I'll be introducing the panelists shortly, as well as addressing some guidelines and the agenda for this session. But before we do that, I'd like to tell you a little bit about myself. I am the head of business development at PLC Group, and I've worked within the telecom industry for the last 30 years, and more specifically within the ICT cooling industry for the last 10 years. I have experience in designing, delivering, and implementing energy efficient ICT cooling solutions for telecom and data centers. Now that you know a little bit about me, let's go ahead and introduce the panelists. First, we have Mohammed Yamas, a senior specialist from Bell Canada. Please go ahead and introduce yourself to the audience, Mohammed.
Mohammed Yamas, mechanical engineer. Even I work electricity in the same time because for sure the 40 years in the business, we learn. And I'm with Bell start in 1986 as project manager for that. And I was not even an employee. After that, I was a consultant engineer for about 25 years. And 2012, I start with Bell as employee, but all in the same office. Everything the same, nothing changed. My phone, my office, everything the same. But instead to have to send the bill, I receive a check and every 2 months, every 2 weeks. And for sure, I'm specialist generally on for sure cooling, heating, and for the especially for Bell Canada, I said for all the equipment area, and for sure for the many years I work even for with the energy to save energy, heat recovery, energy, because we know Bell Canada we have a lot of equipment and we have a lot of energy we can be used to heat building. What we did in many buildings, especially in Quebec, we did couple in Ontario, but the majority done absolutely in Quebec from E to Z. Now we start doing even Ontario region, even the West, because the electricity for sure is much more expensive than in Quebec.
Next, I'd like to introduce Tony Kamaljank, who is a senior advisor with Bell Mobility. Tony, please go ahead and tell us a little bit about yourself.
Hi, everyone. I've been with Bell Mobility now for 26 years. Boy, that seems to fly. Had other experience with working with government and large organizations. My background is as an electrical power technologist, doing basically engineering roles these days. My responsibilities are for a lot of infrastructure at Mobility. And this would be shelters, grounding and bonding, SCADA, telemetry, alarm systems, HVAC, as well as AC and DC power, generators, you name it. This wide breadth of awareness allows me to look at things from a system perspective and find multiple strategies to improve energy consumption, efficiencies, and integration between these various things, looking at a site as a system as opposed to individual items. I sit on a CSA, I'm a voting member of a CSA B72 lightning protection committee. We just released a new standard there, an updated standard B72. I've written IEEE papers, one of which is on free cooling strategies. And I'm a hacker at heart. So in testing out various cooling strategies, I got into some really programmable thermostats and was able to actually implement strategies on them to see what made sense and where exactly would be, let's say, diminishing returns for the effort involved and things like that. Suffice it to say that I think we can do better than just simply air conditioning, and my insight and data collected from sites in the telemetry side seems to support that.
Thank you for that, Tony. Last, we have Yunshui Shen, the CEO and founder of Aersys. Yunshui, please go ahead and tell us about yourself.
Thank you, Jacques, for having me here. My name is Yunshui Chen. I am the founder of Aersys. The last 26 years, we have been working very actively in the field of telecom, data center. We supplied also cooling solutions for semiconductor manufacturing, the equipment for chip manufacturing. We supply also to all these the imaging, MRI scanners, cooling solutions for MRI scanners, and various other industrial process cooling applications. But talking about telecom, we have been working very actively with telco companies throughout the world. We are learning on a daily basis from these experts like Mohammed and Tony on the specific demands for telecom industry. And we are looking forward to have more and more solutions facing the new technology with the 5G network. Thank you, Jack.
Thank you, Yunshui. Thank you all to the panelists for being here today and sharing their valuable knowledge with us. Now, I'll quickly go over some guidelines to keep in mind during the webinar. Today's session will be recorded and will be available for viewing after the webinar. If you have any questions for the panelists, feel free to type them in the Q&A box available on your screen, and we will address these questions at the end of the session. We will also give you some chance to ask questions live during the webinar. When appropriate, please raise your digital hand by clicking the raised hand button at the bottom of your screen. I'm being supported by Zujaja Amr. She is a coordinator here, so if you have any technical questions, please reach out to her in the chat and she will be sure to help you out. We have included some polls in the session, so please do participate. Please take some time at the end of the session to answer the post-webinar survey. The link will be sent to you and made available in the chat. Lastly, please also quickly take a look at the agenda presented on the screen at the moment. To all those just joining us, welcome. My name is Jacques Morvan and I will be moderating this webinar today. Please direct all your technical questions to Zujaja Amr in the chat. So, we know that 5G is raising expectations on availability, speed, reliability, which then poses many challenges on telecom companies, service providers, and their entire ecosystems. They must take certain considerations into account, such as scaling facilities with limited CAPEX, fixed OPEX, and many environmental considerations. Many companies and individuals have tried techniques such as introducing free cooling, raising set point temperatures to minimize the use of mechanical cooling. Now, we have a quick poll for you all. If you take a look at your screen, you'll find the question, which do you think is the biggest concern when it comes to 5G? Please answer by clicking your response and submitting. I'll give you a quick minute to answer this, and then we can share the results. Looks like scalability is at the forefront. Followed by limited CAPEX and environmental considerations. Okay, so it looks like scalability is 50%, followed by environmental considerations at 24%, and then limited CAPEX at 18%. Okay, so I'd like to proceed with questions to the panelists. With that being said, I would like to direct my first question to Mohammed and ask, what are some of the ways you ask to cool your equipment, rooms, and cabinets to save energy?
For sure, what we try all time to operate at higher temperature, for sure, with the return directly to the machine to be able to operate at very high temperature the much as possible, because you know any machine is more efficient absolutely when the return is too high. This will give us even possibility to use even the outside air, because when the return is too high outside, that absolutely all time lower, and you can do really free cooling without without really using any mechanical cooling. And and sometimes if we just maybe 2% instead to use it 100%. The absolutely high temp return, which is what we are looking for all time.
Okay,
Any
that's
question?
interesting. Are you done? Okay, thank you very much, Mohammed. That's interesting. Thanks for answering the question. My next question goes to Tony. I want to, referring to your IEEE paper, what are some of the ways you deal with reducing expenses on cooling for your cabinets and equipment shelters?
Hi there. Okay, and I'm audible, and you can hear
Yes,
me.
we can hear you. Yes.
Okay, wonderful. So my IEEE paper just opened up the discussion at a time when a lot of people were putting up 2 air conditioners on the wall for redundancy, and either disabling economizers or using them, or didn't know how they should be set properly. So it was an exploration into free cooling. And first of all, free cooling may be an option for your for your area, for your location. It has a location variables. You may have the environment or the weather where you live may favor or allow you to do free cooling. I think most of Canada would qualify that way. Now, nobody thinking that we're skiing up here all year round. No. But the southernmost part of Ontario is really on the same latitude as the northernmost part of California. So we do reach kind of south. But by location, I also mean, do you have clean air? Are you next to a farmer's field that would foul your filters, or next to a road surface with lots of dust and maybe even salt spray in the winter? These are all considerations. But the bottom line is that mechanical cooling has a 3-to-1 advantage for heat removal. So you have to burn 1,000 watts to remove 3,000 watts of heat. Whereas free cooling would have 15 or 20 ratio to 1 ratio of, you burn 200 watts on a fan to remove 2,000 watts of heat, or even more, 4,000 watts. So the first thing you have to realize, if you don't have a lot of heat, then maybe the mechanical versus free cooling modes won't make that much of a difference. But as your heat load increases, your ability to save more money using free cooling increases as well. So what's the difference then? One thing we have to let go of is that electronics is not a human. So it doesn't need a very specific and strict temperature control. What we can do is increase the don't care range. So if the heating is now for this is not human comfort, this is equipment comfort. And most of the equipment I deal with has tolerances up to 40 degrees Celsius or beyond. Power plants, 55 degrees Celsius. A lot of the BBUs and radio equipment we use are also 55-degree rated with no reductions in performance. So the most sensitive box in a cell site, for instance, would be the battery. A lead battery certainly doesn't want to live at 40 degrees and will be rather short-lived if you leave it there. Okay, so the free cooling algorithms take advantage of nighttime air to cool things down and average it down. And a lot of my testing and data show that a 4-day moving average, where you can tolerate higher temperatures during the day and bring them back down at night, still leave you with a 25 degrees Celsius average, which is great for the batteries. If a human visits the site, you have to have a way to hit comfort mode easily, so that now you adjust your parameters so that, for instance, if you have an air conditioner, you can operate at 24 degrees while that person's there with, let's say, a 3-hour timer. or 19 degrees Celsius if it's a heating issue and you want to give some creature comforts. So that the control algorithms change because now you're really working where your indoor temperature is going to be like 3, 4, 6 degrees above outdoor ambient, depending on the math here and then the CFM and so on of the fan. Whereas with an air conditioner, you have a flat line. So what does that change? That also changes the algorithm you have to use and the way you use to detect that there's a problem. So if your air conditioner fails and you're sitting there at a solid 25 degrees all the time, some of you are going 25, I'm at 72 Fahrenheit or like 20 degrees. Well, you know, you're refrigerating your equipment. Does it have to be there? It doesn't. So let's say you're at 25 or even 27 degrees with your air conditioner. As soon as it fails, the temperature starts to rise. You could have a simple alarm contact that says at 32 degrees, bang, it's an alarm. But you can't do that with free cooling. If you have a 32-degree day outside, it might be 35, 36 degrees inside, depending on your fan. So you have to account for that. So we have more complex algorithms to trend the temperature in the shelter and then act on an excursion, which might be a delta T by delta time type, DT by DT type of algorithm. So you also have to change your filters more often. You have to have filter replacements. Usually I recommend that this be taken care of up here in the Northern Hemisphere by May, by the end of May, before the heat really comes in with a vengeance. And that way you have your cleanest filter with the least amount of restrictions. And by October, when things are starting to cool off again, if your filter's fouled with a lot of fluff and things that get drawn in, well, that's okay because the fan doesn't have to speed and operate as quickly. I did mention the fan speed. We don't do on and off. That annoys neighbors. That's anybody can quickly understand and hear a fan turning on and off. But if you vary its speed gently, along with which is governed by the conditions, then you can it just finds its stable point and operates there. So that's a quick, maybe not so quick overview of free cooling. You can still have an air conditioning system there that cuts off the top excursion. So if you won't accept anything past 35 degrees, let's say, that's where the air conditioner turns on. But now you have a way where most of the time you're operating on free cooling, and therein lies your energy savings. 5G's putting more, again, putting a lot of radio BBU heat into the shelters. We're up around 4,000 watts now, getting there. And so it's not as high as the old amps days when when all the radios and power and everything was in the shelter and we needed 5-ton air conditioners. But that's gone. But 4,000 watts is about where we're into now. Thank you.
Thanks for your input. Yunshu, given your global experience, I would like to get your input on what Mohammed and Tony have just discussed regarding how they address heat loads in the efforts of reducing energy consumption. Feel free to discuss how various telecom data centers in other parts of the world are also dealing with these issues.
Yes, I think free cooling now becomes one of the mainstream topic or the theme of this industry, is try to take advantage as much as possible of free cooling. I think this kind of effort started like 10, 15 years ago, maybe firstly from Europe, specifically from the mobile network, where they have a high volume of small sites with a relatively low heat load. And there is a huge challenge when they were using mechanical cooling, a challenge on the services, challenge on the power consumptions, all these kind of problems. So they started looking for the solution of free cooling. Just as Tony mentioned, all these kind of technologies, algorithms, the variable speed fans applied to the free cooling technology. But on top of that, I would like to emphasize on, if you're looking at the future of the industry, in telecom, we're talking about 5G. In the data center, we're talking about AI, machine learning, all these type of technology transformations. The heat or the IT load definitely is increasing at exponential rate. But how we address the cooling, I think eventually what ERSIS has a strong belief in, the future will be 100% free cooling. So this is one. So we are actively, very aggressively working on various solutions, talking about 100% free, no matter what kind of heat load, no matter what kind of equipment, it has to be free cooling. So this is one. And I think another technical aspects we're looking at is now everything we're talking about is more or less related to room cooling. So you put the equipment into the room and then you're cooling the room. So this is the existing scenario of cooling. We believe the future will be equipment cooling rather than room cooling. So it means equipment will be cooled by a kind of free cooling technology. So the room, you don't need to cool the whole room. So that's another it's a direction of the cooling. And then the last but not the least is maybe other than technology related to cooling, either rooms or equipment, we may also looking into other aspects like operations, how we optimize the full operations across the infrastructure, cooling specifically, or we're also looking some new financial models to help the telecom customer or data center customer relieve this kind of, financial, we call it burdens or challenges, with some other alternative solutions. Yeah, so Jack, that's my some adding points to this.
Great,
yeah.
Thanks for your response, Yunshui. Now we have another quick poll for all of you. If you take a look at your screen, you'll find the question, what are significant reasons for not using free cooling or economizers? Please answer by clicking on your response and submitting it. I'll give you all a quick minute to answer this, and then we can share the results. Looks like a lot of people are mentioning that the higher summer temperatures are the reason why they don't like to use free cooling, and all of the above. So all of the above is introducing contaminants, lack of humidity, higher summer operating temperatures, and filter change issues. So higher temperatures and all of the above are still at the forefront with 80% of the answers. Okay, all right, so attendees, we will also give some of you a chance to ask your questions live right now. Please raise your digital hand by clicking the raised hand button at the bottom of your screen, and we will unmute you and give you a chance to ask your question. You can also ask your questions by typing them in the Q&A options on your screen. If your question is not answered right now, we will be sure to provide an answer after the webinar. Hi, Tony. Would you repeat the ratios you mentioned for free air cooling and mechanical?
Sure. I generally speaking, I think mechanical is about 3 to 1. Whereas free cooling is we rate it differently. It's a simple straight line linear formula between CFM and temperature differential. But roughly speaking, it's going to be 10 to 20 to 1. So 200 watts of fan can deal with 2,000 watts or even 3,000 or 4,000 watts of heat load. But remember, again, mechanical cooling is operating usually to a flat line temperature, whereas free cooling is only able to work to the differential temperature that you're willing to accept between indoors and outdoors. Watts per Kelvin is the way free cooling is usually rated. How many watts of energy or heat you can get rid of per degree of Kelvin differential. It's very similar to, so that would be the guideline.
Okay, another question for Mohammed. Mohammed, what do you see as the future cooling issues at Bell, and how do you plan to resolve them?
Okay. Now as is mentioned, now for sure for all the new equipment, we use the cabinet with chimney to really to get hot air directly back to the equipment. It could be a chill water machine, it could be the X machine, could be anything. The idea is, as I said, I mentioned, because you know that when we have a chill water machine, if our return is too high, example, our return is 35 or 40 degrees as example. We can go with the chill water, not really to be 5 or 6, 7 degree, or could be even 15 degree if you like. And after that, we deal with the differential pressure between the evap and the condenser would be too small. And that means even you have need a compressor, will not really consume a lot of energy. And the last job we did, that's project we did, we use the chiller, which is from the company Smart, which is variable speed compressor with turbo core compressors. And really, we realize really we consume about 200 to 300 watt only for every 3.5 kilowatt, which is 1 ton. That means really when is really we can run at high temps. I understand the question from some people about the dirt from outside. For this thing, we try today to really, if we use even mechanical cooling to avoid having dirt from outside like that, to run at very high temps. Even we use the chill water machine or use the X machine, because if we can reduce the lift between, but the compressor between the evaporator and the condenser, the consumption would be too low. For this reason, today, you know that, Jacques, I think we developed the new equipment with CO2 machine, which is equivalent of DSE from Liebherr. We use it today in many places, because able to do free cooling. Even that mean without running the compressor, we can do free cooling. But even with the compressor operation, really we with the Smart chillers, which is variable speed compressor, we consume sometime about 300 watt to produce 1 ton of refrigeration. This to avoid really having dirt from outside, as I don't know, one person asked about free cooling operation. Would we have really too much air to replace filter, whatever it is? Absolutely, very good question. Absolutely right. When you use outside air, for sure we have more maintenance. Filter, whatever it is, absolutely is true. Okay.
Okay, thank you very much, Mohammed. Oh,
No
can you
problem.
lift your camera a bit, please? Mohammed, yeah, thank you. Okay, Tony, we're going to go back to the panelists here. I'm going to ask question number 2 to Tony. Tony, what is the role of a well-designed control and monitoring system in increasing operational efficiency?
Yeah, well, that's a big thing. I spent a lot of my time on exactly that, starting with my own little experiments and programmable thermostats. But you know, a mechanical thermostat works with a fixed temperature and then uses a PID loop to maintain that temperature. And that's kind of what you want in your house. You don't want the temperature going up and down. You want it stable. And when there's a change, like when you move from night mode to day mode, and you want things to warm up in the morning, for instance, you turn on the heat or air conditioning, whatever, and the PID loop smooths it out, gets you there with a minimal amount of swing. But for free cooling, we throw that all out. We say, well, look, it's not human comfort, it's machine comfort. So the machine can work from 0 to 40 degrees. Where do we put these limits? So here's the question for you to think about. It's a riddle. It's one that I like to illustrate the problem. You are given an empty shelter. It's sealed, it has a door, but it's an empty shelter with no equipment in it producing heat. So how do you, with free cooling, at what speed should the fan operate to control the room temperature? That's the question for the algorithm. Which one are you about to use? On a simple system, using just a proportional control, you set up a limit and your temperature, your fan speed increases to that limit, which is then 100%, which means that in this riddle, with no equipment in it, your fan may be operating at 100%. If it's 30 degrees and your limit's 27, your fan's operating at 100% and there's no equipment to cool. On the other hand, and by the way, while that fan's operating at 100%, it's also drawing contaminants through your filter, which is fouling your filter. Now, if you operate using, let's say, a delta T method, where you're going to accept a 3-degree difference between indoor air and indoor ambient and outdoor ambient, now your fan operates based on that differential, and you trying to maintain that differential. So a room without any equipment in it producing heat, that fan will hardly turn at all, maybe just turning enough to maintain the control loop stability. So that's the riddle. Balancing operating costs with equipment comfort and longevity. So you don't want, let's say, a lead battery at 40 degrees for long. And if you, again, operate an on-off switch, and you picture that, if your fan stops running at 25 degrees, you'll never get below 25 degrees. So there's an algorithm there to say, hey, at night, if the temperatures drop and dip, let's use it to average down the temperature in the shelter. Adjusting the fan speed to conditions, noise issues. There may be neighbors or someone far away that's a sensitive receptor. So maybe at certain times you don't want that fan operating at 100%. But also, like I said, a fan that adjusts slowly in speed is usually a lot better tolerated by neighbors because they get used to the background noise. So I already mentioned the delta T method that allows indoor temperature to follow outdoor within limits. A seamless way to blend free cooling, economizer operation with mechanical cooling. So for environments where you do hit higher extremes, I would say like in Manitoba, you might have 2 weeks when things get really above 32 degrees Celsius. There's exceptions, I guess you can argue global warming, but really, if it's 2 weeks in a year, that's what you want the air conditioner? Yeah, you can have it. Also, when a user comes in and hits comfort mode, he wants comfort. So give him comfort for 3 hours and then go back to equipment comfort. So now you need an algorithm to detect performance issues or breakdown. Performance issues are things like the filter being dirty. Breakdown is that the fan, these are high quality DC electronically commutated motors, ECM. They tend to made by companies like EBM Pabst, extremely long lifetime, good bearings, but you want to detect the breakdown and act on it. You don't want the legacy method of having, let's say, a temperature a point of 40 degrees C and okay, now I'm in alarm. No, you want to get ahead of it and detect any errors. And what we do is we always want on the mobility side, we're SNMP. So all the equipment, the power plants, everything reports and can be pulled using SNMP. So simple network management protocol, that's what goes towards the NOC. And I've been getting that built into equipment down to smaller devices and boxes. So we don't use contact closures anymore. We use SNMP. That sends alarms directly to the NOC, along with analog values that cause the alarms and a lot of other granular information. Also allows us to do fleet management, so we can pull all the sites and keep an eye on them when things are working tickety-boo. So a logical UI, touch screen or whatever, allows the user to quickly get into modes that, like the comfort mode. I'd expect that to be very easily accessible with a maximum of 1 or 2 but key press pushes, while something like a service menu to test an air conditioner operation or put the system through its paces might be buried a little bit deeper down in the menu system. Logical, visual, status at a glance kind of thing. So there you go. I've asked for the world, but we're there. We're getting it now.
Thanks a lot, Tony. Okay, my next question goes to Mohammed. Mohammed, I would like to ask you another question with regards to what environmental considerations do you have in mind when you are designing your future cooling systems, and how are you planning to deal with that?
Sure, as I mentioned, for all the new equipment, we try to, for sure, to maintain temperature with the equipment. and the space, as Tony mentioned, no need to maintain cooling in the space itself. For this reason, our supply today, we supply 23, 24 degree for our units, sometimes even 24. I'm talking about mechanical mode. We're not in mechanical mode for some reason. No need to maintain room temperature as the old design at 23, 24 degree all time, and even our supply from the machine at 12 degrees, sometimes 12 to 13 degree. Now our supply could be 23, 24, just to maintain the room temperature, just with the people, because we have a tech work in the room sometime. Okay, we supply at 22 to maintain, example, 24, just to offset lighting, the energy from outside. And now the equipment you can suck air from the room, which is about 24 degrees, example, and the outlet is up to 40 degree now, and that means our machine will work for between 40 to 22. That means our delta T is too high in degree F. Imagine, for this reason, as I mentioned now, the kilowatt per ton will be too much reduced. It could be DX, or could be even by that mean natural water machine, or even free cooling. As example, if your delta T high, that means you can do free cooling for more time, instead to do it for the example for 5,000 hours, you can do it for maybe around the year. But as I said, the idea is if we maintain, we like to not have, or we cannot have really outside air for some reason. We operate at very high temps to reduce consumption, because delta T is too high. Whether it's too high, absolutely the efficiency of the machine or on the chillers, it would be absolutely very high too.
Okay, thank you very much, Mohammed.
No problem.
Okay, next question goes to Yunshui. Yunshui, considering the telcos are dealing with a lot of CAPEX due to 5G rollout, what are some of the innovative cooling techniques and financial models that could benefit service providers?
Just to go back to the question about free cooling. So we did some research or experiment with the OEMs with some equipments. Like servers, like I mean, we are really trying to understand the working temperature of those chips, electronics on the equipment, and the relationship with the either air or liquid temperature related to cool those equipments. So one of the tests we did in this year, 2021, is the chips are working at the temperature about 80 degrees Celsius. So below 80 degrees Celsius, that chips will work reliably without any issue. So what is the temperature allowed, air temperature allowed to cool that chip, to keep that chip under 80 degrees Celsius? We do a lot of tests. So it comes up to 45 degrees. So it means if we have 45 degrees below air temperature blowing into that equipment, those chips can work under a normal condition without any issue. And also we talked with the thermal engineers in those OEMs. So they, of course, have their internal algorithms, how to regulate the chip's performance related to the temperature. So it means if temperature is reaching or beyond 80 degrees Celsius, they will, downloading, let's say, reduce the speed of those chips just to keep the chips working on the right temperature. So with this being said, so I think we may still very conservative on the air temperature side from the either telco or data center. I think talking about free cooling is all about pushing the boundary either on temperature setting, also on delta T. So if we mention the delta T as both Mohammed and Tony mentioned, the delta T also contribute greatly to the efficiency of free cooling. If we're talking about return air temperature, not only supply air temperature, return air temperature. So if we can significantly increase the delta T, so we can really magnify the efficiency that we can get from free cooling. Okay, so then come back to your question. I think other than all these technical solutions. And we should also look at this aspect from two other aspects. One is, let's call it operational. I think Tony already talking about a lot of algorithms actually related to the maintenance, related to how we can save costs from the operations. I think that's also one of the key, is trying to optimize, reducing the number of visits, reducing the number of the maintenance expenses. That's one of the key aspects. As a product solution provider, we should work together with the customer, with telcos, to achieve this. And I think we do believe we have many things we can provide, like the remote monitoring and control, like the filter algorithm, the filter configurations to create a larger filter, to use not only the switch but the sensor to give you a kind of foreseeable consumption on the filter. All this can be done, I mean, through this latest technology. And last but not least, as I said, if we can also looking at cooling infrastructure, cooling as a service, instead of owing all this as an asset to putting on the balance sheet of the customer, and just to take it away and moving into a service business model. I strongly believe this can really create value for telecom customers and let them more focusing on their key business, which is to provide data services to their customers. Yeah.
Okay, thank you, Anshu, for the insightful answer. Okay, so now we're going to go to a live Q&A. With that being said, we'll go ahead and take some live questions now. Please raise your digital hand by clicking the raised hand button on the bottom of your screen. We will unmute you and give you a chance to ask the question. I will also read out some questions that were sent earlier through the Q&A option. Feel free to ask your questions in the Q&A box if you haven't already. There's a question for Tony. Based on prior experiences, do you see cost savings by converting or upgrading existing sites to new free cooling or combo units?
Well, first of all, you have to look at your utility to see if there's still incentives available for you to make this conversion. Usually there are. A large portion of my program was based on tapping into those incentives. So that's an artificial thing, and gets you moving. Now look, we're also faced with older air conditioners that are past their prime. They might be R12, so they cannot be serviced. As I said before, as we moved away, older shelters that had 5-ton or 2 5-ton air conditioners don't need them anymore. We have large shelters that are like 15 by 25 that are largely empty with only 2 racks in them today. So there's incentives and reasons to replace those units. And when you have that opportunity, you're going to choose whether or not you're going to go free cooling only, or whether you're going to go with a hybrid approach. For instance, something that can adjust between free cooling and mechanical cooling. Or, you know what, sky's the limit. Anything's possible, including, let's say you have 2 air conditioners, you remove one and replace it with a free cooling system and leave the other one there as your air conditioner. I mean, there's so many options available to you. We didn't talk about cabinets, and that's a really, really tricky business. We've developed these solutions as well for cabinets. And as you know, in a cabinet, if you lose AC power for an air conditioner, you could be overheated in minutes. Similarly, we've been running out of air conditioner capacity, like a 6,000 BTU will not cut it anymore. 10,000 probably won't either. We're there. And if you even think about DC air conditioners, well, you know what? We're having enough challenges powering 5G, and the BBUs there, it's a beast. They're very hungry. So, you know, the lowest power consumption is from free cooling. Now, You're going to have lithium batteries as well, which don't charge below freezing. So that's another issue. So it's a complex world.
Okay, thank you for that, Tony. So here's a question for Mohammed. Mohammed, what do you have any concerns about water consumption for higher heat load demands in the future, especially areas with water shortages? What plans for the future?
Okay, we when I mention shore water, does not mean using cooling tower. That mean normally when you have a closed loop and our condenser is air cool. We start 2 years ago to really to stop using cooling tower to avoid consuming water and at the same time to avoid really the chemical product. As you know, Legionella across Canada, it happened sometime in Quebec a couple years ago, and now the government is so hard with all the company and to save really water and not to be really all time you need water in case something happen. We stop using cooling tower when the shore capacity is 250 ton in less. Now we are using just the air cooled chillers, 250 ton and lower. Will not use anymore the cooling tower for the I mentioned. No chemical and no water consumed.
Okay, thank you very much, Mohammed.
No
Here's
problem.
a question for Yanshui. Hector Borrego is saying that you mentioned free cooling all the time is the objective. What timeline do you envision for this to be achieved?
Okay, I think in the next 5 to 10 years, I would say either telecom and data center will be fully on board on free cooling. So it means mechanical cooling will be obsolete. That's my forecast for this, because we are actively working on either fresh air free cooling, or chilled water free cooling, or on the real liquid cooling to the chips. So if the liquid cooling to the chips is adopted as an industry standard for all these equipment OEMs, then the mechanical cooling will be gone forever. Yeah, because as I said, the chips are working at the temperature of 80 degrees Celsius. Yeah. So with the liquid cooling, so the liquid can be 60, 65, even 70 degrees. So that will give the free cooling for everywhere in the world. Every geographical area can be using free cooling. Yeah.
Thank you for that, Yanshui. Tony, free cooling works very well for most of the year, but as the equipment loads increase, it is becoming harder to cool the equipment with ambient air. At what point do you think some sites will need to transition to a combo unit?
So that's a good question, and it's a real issue. The problem is global warming and the temperatures we're now seeing in the summer. You can take a statistical representation. In Toronto, the numbers used to be that there'd be only 32 or 36 hours a year that temperatures were above 30 degrees Celsius. And you go, well, I was shocked to see that number. It's like, really? It certainly feels like it's warmer more of the time than 36 hours. Last few years, it has been because of, I guess, global warming. But, you have those peaks at a certain time of the day in the afternoon, and then at night, things go back down to 22, for instance, even on the good summer nights. The place to look for that answer would be places like Australia, where they have 40-degree days. So to your point, you probably cannot operate free cooling at that level. What they do is operate air conditioning starting at 35 degrees. We also used equipment for cabinets that had a very small heat exchanger, like 50 watts per Kelvin, coupled with an 8,000 BTU air conditioner. And the transition point also was 35 degrees inside that cabinet to go to mechanical cooling. Now, the heat exchangers are not very good. They need large temperature differentials to work. So in the winter time, that 50 watts per Kelvin heat exchanger could keep up. But in the summer, the interior of that cabinet was at 35 degrees, which is, you don't have humans inside that cabinet, you have equipment, and that's perfectly fine for that equipment. So the other thing that you have to kind of think about is the location of equipment in relationship to each other. If you have a source of a large amount of heat, you probably want that closer to the exhaust side so that that heat is expelled without contributing to the temperature of other equipment. Whereas things like your battery, you want it seeing the air coming in sooner than anything blowing by other equipment. So there's some thought required as to the layout of the room. It's not just willy-nilly like we used to do with air conditioning. In fact, we operate, and I've designed sites with chimneys in them where we're forced to have the actual radios inside the room. They operate at 50 degrees C because they're meant to be outside on a tower. Why air condition them? So they operate at 50 degrees C, and we expel that air directly outside, while the rest of the room is a different climate at whatever the free cooling system is supporting. So yeah, it's a little bit more complicated, but you can do it.
Thank you very much. Another question from Mohammed. When you are trying to justify your increased cooling costs, how do you justify your business case?
What's the question is?
When you're trying to justify your increased cooling costs to your superiors, how do you justify your business case?
No, normally when we, for sure with the add equipment, for sure sometimes you need more cooling. That means we cannot really maintain our consumption, our cost. If the company add more equipment, we add more equipment, that means we have more return from the client, right? But for sure, in the same time, we try to use the best technology to maintain our consumption. Even the company add more and more equipment by doing in our side, just as mentioned, free cooling operation, use more efficient equipment like VFD, like more control. We have now today with DDC control. We can do what we like today. We can reset our temperature. Many things to be done, but sometimes if they add more and more equipment, we have a limit. We cannot really maintain our consumption if we add more and more equipment. Some places, yes, we did it because we had a lot of opportunity to do something in energy. But once it's done and no any more technology to be used, what you can do? We consume, we have to pay.
Okay, thank you very much, Mohammed.
No
At
problem.
this point in time, I'd like to wrap things up. In terms of the questions, we are nearing the end, so I would like to thank everyone, the panelists, the attendees, the teams that worked on this webinar. Thank you so much for your time and effort today. Please make sure to answer the post-webinar survey. Live it long and prosper, says Tony.
One thing, Jacques, we didn't mention one thing. I don't know if I can say that now.
Sure. Yeah, go ahead.
Okay, that's what we talk. Even Bell now, we are working for different company to build new equipment. As you know, that the CO2 machine, which is a new equipment, and we are, I think, the first company in the world. I think we start using the CO2 as Freon, and now we have more than 55, 60 units installed across Canada, as you know, because I'm working from coast to coast, and now we have a lot installed in Ontario region. We have in Quebec too, but we continue really working, and I just closed the chillers with CO2 using Freon as Freon CO2, and same time heat recovery chiller, which is the first one even in Canada using CO2.
Okay, thank you for that. Please make sure to answer the post-webinar survey that will be sent to you and is also available in the chat right now. And we would really appreciate it. We would also hope you enjoyed the session, and we look forward to seeing you in the future webinars.
Thank you.
Thank you once again, and have
Thank you.
a good day.
Thank you. I appreciate it.